Welcome to Code Report. I'm your host, Connor Hoekstra. Last week we had 6 contests, starting off with from Hacker Rank, the 101 Hack 55 contest. We had 2 contests from Code Forces, round 494 on Tuesday and round 495 on Thursday. We had the start of the 10-day long Code Chef July Challenge on Friday. At noon on Saturday, we had round 3A of the TCO 18 Top Coder Tournament, and we also had, of course, the weekly LeetCode Contest 92 on Saturday evening. Taking a look at the top 10 leaderboards, here they are. We have highlighted the individuals with multiple top 10 finishes. So Natsugiri taking first in the Hacker Rank contest, second in round 495, and fifth in LeetCode. Yui taking 7th and 7th in both round 495 and the Hacker Rank contest, as well as third in the LeetCode contest. And we also had Quailty for in placing 10th and 9th respectively in both of the Code Forces contests. And the top 50 individuals that competed in the TCO 18 round 3A qualified for round 4. There's going to be round 3B in roughly 1.5 weeks from now if you weren't able to qualify. So some big people on, or big names on the top 50 leaderboard. And in the top 10, of course, you can see Blue Mary, LHIC, Tourist Petra, and others. In today's video, we're going to be covering the solution to problem 3 from the LeetCode Contest 92 entitled Prime Palindromes. The problem is super straightforward and has a very short problem statement, and that is find the smallest prime palindrome greater than or equal to n, which you are given. And note that n is going to be between 1 and 10 to the 8, and that your answer is guaranteed to exist and be less than 2 times 10 to the 8th. So the examples that they give us are listed right here. If we're given 6, the smallest prime palindrome that is greater than or equal to 6 is 7. For 8, it's 11. That's because 9 and 10 are not prime, and 10 is not a palindrome. And for 13, it's going to be 101. So we're going to do something a little bit different for this video, and that involves switching over to Visual Studio. So what we're going to do to solve this problem is basically generate via brute force every single possible prime palindrome, which is going to take longer than the time requirement, but we're going to do this outside of our actual solution. So we're just going to generate the numbers, store them in a set, and then call lower bound and pass to lower bound our input n, and this will be a constant time solution. So you can see here, this is just the code to generate our prime palindrome. So we have an isPrime function, which is pretty straightforward. Most of you should be familiar with a function like this, basically just checking if our input n is divisible by 2, 3, and other numbers. If so, it's not prime, and if you can get through this loop, then it is prime, so return true. And then for our isPrime palindrome function, all we're doing is we're converting our input n to a string, then making a copy of that string. So we've got both s and t, and then we are going to just reverse s. So then we can return if s is equal to t, so that covers the palindrome part, and it's also prime. And so with these 2 functions, we basically have everything we need to generate. I've added this function skip, which is just going to increment our I a little bit faster for the purposes of this video, because I'll be showing the numbers being generated. So we know that if we have an even number of digits in our input, it can't be prime palindrome because it'll be divisible by 11, except for 11 itself. So when we're at 1,000, we want to basically skip up to 10,000, and the same for the following 2 numbers. And then we also know that if our digit or our number starts with a digit that's divisible by 2, that's not going to be a prime number either, because that means it's going to end in 2, and therefore it's going to not be prime. So what we're doing here is we're just getting the first digit that's going to be stored with J, and then we're keeping track of the number of digits in our number. And so once we have that, we can check basically, is our first digit divisible by 2? If so, skip to like the next biggest number. So if you're at 200, you count the number of digits k, and then so you add to 200 100, which is going to be basically 100 to the power of, or 10 to the power of the number of digits minus 1. So 200 plus 10 squared is going to be 200 plus 100, which will get us to 300. And it's also the same thing if the first digit's a 5. So we know that any number that ends in 5 is divisible by 5, so we can do a skip there. But you don't really need this code, this function, for generating them. This is just to speed things up, like I said, for the purposes of this video. And so what we're going to do then is we're just going to loop through 1 to 2 times 10 to the power of 8, which is what we know our answer is going to be in. If I is greater than 10 to the power of 8, we want to end our for loop as soon as we find one of the numbers, because we know that the input is going to be less than 10 to the power of 8, and so we only need one solution that's greater. And we just print out anytime we have a prime palindrome. So if I run this, you'll get the following, and it's just going to quickly generate all your prime palindromes. This takes roughly, I think, 20 or 30 seconds. We're almost there. Just a couple more. And we're now done. So what we want to do is come back here. We want to select all, copy, and then go to our LeetCode. And so once we're here, we just want to do the following. Get rid of this last comma. And because this is iterator, we need to dereference it. And if we submit this, we should get an accepted solution. So this was sort of inspired by discussion, because there was a post for a solution, and some people were sort of responding to it like, that's not an actual solution, but it definitely is. I guess the solution, it should be included, the code that was used to generate it, to sort of show people it's not very useful just posting the numbers. But yeah, this is a definitely valid solution, and it might take a little bit of time to generate those numbers. But it's totally valid, and this happens in competitive coding contests all the time. So the time complexity of this solution is constant, as mentioned before, and yeah, just trying something a little bit different for today's video. Taking a look at the contest that we have next week, of course, we have the Code Chef July challenge that will continue to go on throughout the week. We're going to have 2 contests from Codeforces, round 496 on Monday and round 497 on Friday. We're going to finish off the week with, of course, the weekly LeetCode Contest 93 on Saturday evening. And also we have the first contest of a new series that's being put on by Hacker Earth. That's only going to be an hour long, and that's going to be the Hour Storm. So that's taking place this Saturday, and it'll be the first version of this contest.
As always, if you enjoyed this video and found it helpful, hit that like button. If you want to see more, make sure to hit that subscribe button. You can follow me on Twitter for reminders 30 minutes before contests start, and you can find all of the code shown in my videos on my GitHub page. Thanks for watching, and I'll see you in the next video.